So this is problem 3. The question is, for the radial network shown in the figure, a three-phase fault occurred at F. So three-phase fault means we know that it is a symmetrical fault. So in examination also you should not get confused whether it is a symmetrical problem or unsymmetrical problem. If three-phase fault they have mentioned, then obviously it is a symmetrical problem, and the steps for symmetrical problem you can follow the same steps. So here they're asking to determine the fault current, that is IF, and then line voltage at 11 kV bus. Okay, so where is 11 kV? Here it is. It is 11 kV. So in this bus, what is the bus voltage during fault, at or under the fault? We need to find out. So let me observe the network here. It is a at 11 kV bus. There are two generators connected, G1 and G2. G1 having 10 MVA, G2 is also having 10 MVA power, and then reactance is 15% for G1, 12.5% for G2, and it is connected to a transformer T1, and this transformer is obviously 11 kV to 33 kV, because we know the bus voltage levels are given. So obviously it is step up transformer, that is 11 kV to 33 kV, and the transmission line after the transformer 1 is about 30 kilometers overhead line, and the impedance is given for the transmission line. After 30th kilometer there is a bus. That bus is connected to a transformer 2, and then that transformer range is 33 kV to 6.6 kV, that is it is obviously a step down transformer having 5 MVA and 8% reactance, and this T1 value is 10 MVA and 10% reactance. So these are all the values they have given. After 6.6 kV bus, after 6.6 kV bus, it is connected to a 3 kilometers cable. 3 kilometer cable having impedance Z is equal to 0.135 plus J 0.08 ohms per kilometer. Here also in transmission 1, after transformer 1, the overhead line for 30 kilometers, the impedance is given 0.23 plus J 0.36 ohms per kilometer. So this is the network they have given. For this network or for this single line diagram, we need to find out the fault current at F. Where is F? F is after the 3 kilometer cable, there is fault occurred. So around 33 kilometers away there is a fault, and this fault and this system having different components or elements, we need to follow the symmetrical fault analysis steps to get fault current as well as the voltage. Right, so let me start how to do it. So solution. So first we will check for this fault current, that is if actual we will find. So for that, what is step 1? Before step 1, let me assume all the bases, problem bases. So I am selecting selection of base MVA. First we will select. So I'll take the maximum of 100. Maybe here it is 10 only. Let me check if I take more than the maximum value, what is happening. Let me check for 100 MVA. My problem, what power base, I have taken 100 MVA. Okay, you can take 10 also, it's your wish, but I'm taking 100 MVA, or you can check by yourself what will happen if 10 10 MVA if you are taking as a base. That is your wish. Okay, then voltage base in generators. In generators,
So can you explain why we took 100 MVA sir again?
Sorry,
So why we take 100 MVA
you
again
can
sir?
take 10 also. You can take 10. I'm taking, say, for example, if I take 100, that much times I will change the base. That's all. So I am taking the worst condition. If something happened in between, so what is the worst condition? It may increase the power or some shortages happened. For that, I will take maximum value. Even I can take 10 MVA also. It's not a big deal. Both are same.
Okay
You
sir.
can try with 10 MVA. It's not a big deal. Okay, the same problem you can use with 10 MVA. Answer will be same. Okay, so
Okay.
voltage base in generator is equal to, I'm taking 11 kV because near to generators I have 11 kV only. So generator is connected together 11 kV. So I'm taking voltage base as 11 kV in generators. For overhead line, for overhead line, my value is 33 kV I'm taking, and for cable you may take 6.6 kV. So why I'm taking 6.6? Because the voltage range during my cable part is it is stepped down to 6.6, and after overhead during overhead line my value is step up to 33 kV. That is from 11 kV to 33 kV. So I'm taking for overhead line as 33 kV. These are all my power and base. Sorry, power and voltage bases I am considering. It's not, see, in textbook they have used 100 MVA, but in other textbook they have used the same as the maximum value. But it is not a big deal. You can use 10 also. It's not a big deal. Okay. So what is next? I mean, what is the first step?
So drawing a single line diagram, but we already have it sir.
Exactly. Very good. So we are already having the single line diagram given in the question. So what is next step?
So XPU for each element.
Exactly. To find the reactants for all the elements. So let me start from G1 and G2, right? So I'll go for next page. Before that, just a minute, I'll take the question. I can crop, I think. Okay, so I've taken the question. So let me start step two. So reactance of G1. So what will be my reactance of G1? The base is, what is the base?
100 sir,
So
but
what is the base given there?
10 sir.
So can we change the base? So tell me the value of R1 after changing the base. Sorry, XG1. XG1 is equal to J 0.15 into base MVA, new or old year.
New sir.
Okay, here it is new, and here.
Old sir.
So what is new and what is old value here?
Sir, wouldn't the new one be 10 MVA sir?
New will be,
10 MVA.
how it will be 10 MVA? New is the change one. So I want to change to 100. So 100 will be my new. Correct or not? Divided by old is 10. So what is the value? So what is the value, ma?
What about into the kVA square, sir?
Huh?
What about into kV square, sir?
KVA square obviously it is 1. 11 divided by 11 whole square 1 will be. So I can eliminate it.
Okay, sir.
So what is the value?
1.5J.
So J 1.5.
So similarly find out, please find out for xg2 also, please everyone. Please everyone do it. So what is the value?
1.25J.
1.25 J, sir.
And for T1? XT2. T1 is correct, right?
So for T1 also voltage is 11 kilovolt only, sir.
Voltage is? Yes. We can consider the low voltage side. We'll consider the low voltage side. Even if it is going for high voltage side is 33 kV. So 33 kV divided by 33 kV whole square. So it will be same only, right? Why? Because I am considering for overall voltage at high voltage side it is 33 only. So it is now no change in base for voltage for me. Correct or not? Do you got my point? Say if you are going for high voltage side or overhead line side, that time my voltage is 33 kV. Correct or not? So if I'm calculating anything after my higher voltage side of the transformer one, so I am considering already what voltage as a base? 33 only. So new as well as old will be, or sorry, old divided by new for kV will be same. The whole square will be same. That is 33 divided by 33. The whole square. So it is 1. Yes or no? Please tell me.
Yes, sir. Yes, sir.
Okay. So what will be xt2? J 0.08 into 100 divided by how much? 42.
5.
Very good. So what is the value? Okay. So next, next year, one thing we need to consider in step 2, we said we need to find out reactance. Say for example, we usually assume there is no resistance. That is what in the first class I have sent. We usually we don't. We will consider resistance will be 0 for the transmission line. Suppose in the question if they are given resistor or if they are given impedance value, then we need to include as not only reactance, we need to include impedance also. So for example, in the transmission line, impedance is given. So we can still, in step 2, it is not only reactance, we can still find out the impedance also. So how to find out impedance for transmission line? That is overhead line for 30 kilometers. If they are not given only reactance, they are given not impedance, then we can take. But if they are given resistance value, otherwise if they are given impedance, then we need to include impedance value also. Okay, in the question newly they have given the impedance value for overhead cable separately, and then overhead line separately, and cable for 3 kilometers separately they are given impedance value. So instead of reactance, we need to find out impedance for the transmission line. So we know that Z into MVA base whole divided by KV base, the whole square. So this is the formula to find out the impedance. That is the overhead line total impedance. If you want to find out, this is the formula. And also we need to find out for not a single kilometer, for 30 kilometers. For 30 kilometers we need to multiply this with into 30, this value with 30. So apply the formula and tell me the value. What is the overhead line impedance value?
Sir, MVA will be 10, no, so there.
MVA for overhead MVA how much? 100 only for all area, whether it is in generator or overhead line, and for cable, all three areas we consider only 100 MVA. So only 100 MVA will be, that is 100, and Z value already they have given, multiplied with 30. And what will be KV base?
11, sir.
No, for overhead line KV base for,
33 kilowatts.
very good, it is 33 kilowatt, because we consider 33, that is the maximum voltage in the transmission line there. So three different bases for kV we have taken. Okay, so here we need to consider 33 kV base whole square. So what will be the value? So it is nothing but 30 into 0.27 plus j 0.36 into 100 whole divided by 33 uh, whole square. Okay, what will be the value? You need to think this is MVA and this is KV. So 100 should be, tell me the final value.
So it will be convert 100 MB again.
Yeah, obviously, because in denominator we are having KV, right?
Yes, yes, sir.
Sir, is it 0.74 plus 0.99i?
Very good. This is the correct answer. 0 point.
74 plus 0.99i.
Okay.
Yes.
So how many of you got this value? Okay, fine. So
So same, sir.
very good. So we'll go for next. What is the pending? What is the pending here? We find out for T1, T2, G1, G2, and then overhead line we done. And what is the only pending?
Cable, sir.
Very good. So now we need to find out cable impedance. So apply the formula and tell me the value. Please do, everyone. For your convenience, I will copy. Sorry. Yeah, for cable impedance is equal to same formula Z into MVA base whole divided by KV base the whole square. So here what is KV ma? What is KV value?
6.6.
Very good. And MVA is 100 as same as common for all entire network. We are considering the maximum of 100 MVA. So Z value is already given in the question.
Sir, into 3 no, sir.
Into 3 exactly. Very good. So for 3 kilometers. So we need to write 3 into 0.135 plus J 0.08 into 100. Please take care. This is MVA whole divided by 6.6 the whole square.
Sir, is it 0.93 plus 0.55 J?
Very good, correct answer. So cable impedance is equal to 0.93 plus J 0.55 per unit. So this is the cable impedance. What happened now is we have find out all the reactance and impedance in the entire network. So what is next step?
Drawing single line diagram.
Very good. Single line.
Single line reactance diagram.
Very good. Reactance or impedance, both are same here because they have given resistance value. So how it will come? I'll draw here. So I'll convert a generator to a single generator because both are having one angle 0, and then I'll have two reactants for generators, and then I will have a reactants for transformer T1. This is XT1, XG1, XG2, and then impedance for overhead line. I'll write line here. That is, I'll write the value of that is how much 1.5. J is there. Consider there is J is equal to 1.25. This is 1.0, and this value is 0.744 plus J 0.99, and this is for transformer 2 T2 XT2. This is Z L, and this value is 1.6. And for cable I'll write ZC. This value is 0.93 plus J 0.55, and here the fault is occurred F. Okay, so this is the single line impedance or reactance diagram. What next, ma? What next?
X equivalent.
Yeah, you are going to find out the X equivalent now. Please find out the X equivalent or total impedance or total impedance you can find out because we are having resistance value also here. Yeah, find out. So what are the values will be there? So before that, what I want to do, here one parallel combination is there. So convert this parallel into series and then do add all the things and then you will get the value. So what will happen? 1.5 into 1.25 divided by 1.5 plus 1.25. So what is the value?
0.68, sir.
Very good. Add it with all other the add it with xt1, zl, xt2, zc, and tell me the value, total value. Total impedance is equal to how much you said? It is j 0.68681, right? Plus j 1.0 plus 0.744 plus j 0.99.
So 0.25 plus 2.88 J.
No ma. Once again check whether all values are added. 1.6 plus. Maybe I also will be wrong, but anyway, we'll check for others also. 0.55. So add this.
So 0.93 plus 4.5 J.
0.93. No, let me check for others also because I'm
Sir,
getting.
1.67 plus
Yeah,
4.82.
yes, that I'm getting the same. Who is that second person? I'm getting the same value.
Sir
1.6.
Sarthak.
Who's ma? Who is that?
Sir Sarthak.
So, okay, okay, okay. So I think I'm getting that same value. Let me check with others also.
Yes, 1.67 plus 4.8
Okay,
J.
okay. Total impedance is equal to 1.674 plus J 4.82. So this is the value I'm getting. I think most of you are getting the same value. So what is next step? Step 6.
So fault current.
So we know that if per unit first we'll find out, then we'll go for actual, or even if you know base value directly multiply to get actual, but we'll go stepwise only to get the step mark. So if per unit is equal to, we know that it is 1 divided by j x equivalent. So 1 divided by j will be obviously it is minus, no, we'll go as per the value. So 1 divided by 1 plus, sorry, it is 1.674 plus j 4.82. So what is the value you're getting? Here actually we are writing impedance, not a reactance, because we are having the resistance value also.
So 0.064 minus 0.18.
Very good. Minus 0.18, yes. J 0.1, sorry, 0.185. So this is the value I'm getting per unit, for per unit. So please find out for actual. So step 7 is step 7 is to find out the actual value. So what is the, how we can find out the actual value? So if actual,
IFP into I base.
if per unit into I base. So how to find out I base? I base is equal to, we may take like S is equal to root 3 line voltage. If you are having line voltage, we'll go for line voltage. So we know at the fault, what is the line voltage we are having? At the fault, line voltage is how much? How much ma?
0.6, sir.
Yeah, because here we got the fault. at 33 kilometer. At 33 kilometer, the third bus value is 6.6 kV. So obviously here the voltage is flowing is 6.6, and also we know that there is no any voltage drop, but even though of small resistance, especially given in the question, there will be drop. But anyway, we can ignore this drop by comparing to the fault occurrence here. So we'll take the entire voltage is 6.6 kV here, right? And also, what is the S value we have considered for this question?
100, sir.
Exactly. Even though the maximum value 10, but uniformly we are finding out our base as 100. So we'll use the same power here. So I base is equal to 100 into 10 to the power of 3 divided by root 3 into 6.6. So how much value I base we are getting?
Sir, 8747.73.
8747.73
73.
amp. So see this value having both resistance and this reactance value. So can we convert this into what in normal value in radian?
Yes, sir.
So how much value we'll get? So I think 0.196 we will get with the angle of minus 70.47. So from this only, if you are taking the magnitude, so that will be your IF per unit, IF per unit ampere in ampere. Am I right?
Yes, sir.
Yes.
Okay. So what will be my IF value then? 0. I'm taking only the magnitude 196 into here also have magnitude of base, that is 8747.73. So
174.55, sir.
how much more?
1714.55.
0.55 is correct answer. So this is the value of IF actual. So what is the conclusion here? If three-phase fault occurred at 33 kilometer away from the generator, the current will flow, that is the current will be the maximum current will be 1714 amps. So your protection device also should withstand this much of current. It should not destroy, and it should not what mingle with the normal working condition system. It should isolate from the fault place. Correct or not? So one part of the question we have done. So first they have asked to find out the fault current. So we find out the fault current. So next they're asking line voltage at 11 kV bus under fault condition. If fault occurred, then what will be your voltage at 11 kV bus? That is the question they're asking. So how to find out that? So again I'm taking the same diagram. So this is the what network or single line reactance diagram we created, we formed. So from this 11 kV is this point. This point is 11 kV bus. Correct or not? Because after generator there is a bus. So they're asking voltage at this point. So if they're asking voltage at this point, we need to know impedance only from here to here. So what will be the impedance of places under this area? So how to find out the impedance during, I mean in that place is just add all the impedance from that point. So that point means that 11 kV, after 11 kV point. So impedance between 11 kV and fault location. Impedance between fault location and 11 kV will be how much? J 1.0, that is nothing but for transformer, and then plus for ZL that is 0.744 plus J 0.99, and for T2 transformer to how much it is 1.6 J 1.6 plus ZC cable, that is 0.93 plus J 0.55. Okay, so how much value it is total? Please give me the value. So it will be 1.674 plus J 4.14, and if you convert into the, if you're converting this, you will get 4.43 angle 68.031. And if you are taking this as the total impedance between fault and fault location and then 11 kV, then voltage can be calculated by bus is equal to 4.43 angle 68.031 into IF actual. So what is IF actual? Total actual value. Sorry, IF per unit value is, that is IF per unit value.
1.96, sir.
Okay.
1.96.
So multiply and tell me the value. Let's check whether mine is correct or not.
5.29, sir.
Sorry.
5.29, sir.
3 into IF. IF is 0.195 angle minus 70.47. So please convert this degree into radian and then multiply. This is per unit value we are calculating. Voltage at 11 kV per unit. I'm getting different value. Just a minute, I will cross check this also. Formula is correct, just a value we need to convert.
So should we calculate in terms of radians or the normal polar form, sir?
Okay, both of, if you are calculating both in polar form, no problem. Answer also will be in the polar form. I also will cross verify. You also will solve this, please.
Zero 0.87, sir.
That is correct. Perfect answer. 0.87 angle minus 3, right?
Yes, sir. Minus 2.9. Yes, sir.
Okay, per unit. So this is the what for per unit voltage value. But in question they're asking not per unit. They're asking only voltage. So only voltage means it is obviously we need to find out the actual value. So for voltage actual at 11 kV will be V actual is equal to 0.88 into 11. So how much value? Because this is per unit, multiply it with 11 kV. That's all. So what is the value? That is 9.68 kV is the actual voltage at 11 kV position. So this is the final value. So much. I mean, everyone getting this value, right? V actual.
Yes, sir.
Okay, that's all. So this is again an important question, and this is a textbook question. So you may get a problem like this also for examination. Please follow this. Okay. So we'll see in the next class.